Good day. Good day, everyone. Good day to our hydrology advisor, Miss Kristine Cervancia. We are the Group 1 having a research paper that focusing on flooding. So I am Gerald Ramos that will start our research paper. Then we all know that Philippines is one of the archipelagic nature and setting. And the country is comprising more than or approximately more than 7,000 islands that naturally surrounded by numerous bodies of water such as oceans, rivers, seas, lakes, and etc. We all know Philippines is located along the area of equator or we all know the typhoon belt where numerous of storms and typhoons usually come through it. And each year, we all know that 20 typhoons or over 20 typhoons come through the country. That's why, due to storms and typhoons or large amount of water that causes its flooding. We all know flooding is the simple term is overflowing of water, usually caused by intense rainfall and massive typhoons. Flooding has always a big threat in the Philippines, which also in economically it approximately causes a lot of damage that reaching $100 billion in a single severe typhoon landed in the country. In accordance to statistics based on Andres et al., Typhoon Telma, one of the known typhoon that landed in the Philippines, brought disaster in 1991, where it affects mostly the city of Ormoc, causes nearly 6,000 deaths and nearly 700,000 people. Another is the more than $70 million of damage due to Typhoon Winnie. Due to the natural phenomena, numerous of people, lives, and properties has been hit and affected due to its problem. So, we the researchers come up to the study that due to curiosity and willing to study the cause and effects of flooding, we limit the scope in the Santa Rosa-SILAG SUBWATERSHED, where it encompasses the municipality of Santa Rosa, Binyan, Laguna, and the Silang, Cavite. You all know that Santa Rosa-SILAG SUBWATERSHED is one of the aquaculture and the industrial use for agricultural and industrial use for the fast developing cities like Santa Rosa, Binyan, and Cabuyao. Due to innovation and industrialization, it changed the landforms, the fast growth of population, the reduction of capacity to hold the water flow during the rainy seasons that affects a widely pollution, flooding, and scarcity in water use. So with the researchers continue to prevent or study how to help this city to check or to analyze what is the possible assessment and to risk the reduction to reduce the reduction of this complication. That's why we, the researchers, entitled our thesis paper or research paper, Assessment of Causes and Effects of Flooding on the Santa Rosa-SILAG SUBWATERSHED. Flooding is one of the risk effects of numerous resources and living of the community that becomes a threat, especially on the areas that near of water bodies such as lakes and rivers. Like the Laguna de Bay, numerous of cities are using it as a agricultural and industrial use. In the statement of the problem, the researcher will focus on the causes of flooding on the vicinity of the Santa Rosa-Silang subwatershed and also the effects of flooding on the vicinity of the Santa Rosa subwatershed. This statement of the problem will focus on how we will help the community to understand the cause and effect of the phenomenon to the community and help local governments take action to their particular area and give awareness to the people nowadays and to the future.
I am Patricia Marie de Luna and I'm going to discuss our study's objectives, and it is as follows. First, to assess the causes of flood risk on areas along the Santa Rosa-Silang subwatershed. Next is to determine the effects of the several flooding on areas along the Santa Rosa-Silang subwatershed. Significance of the study. The study will aim to assess the causes and effects of flooding on the vicinity of the Santa Rosa-Silang subwatershed. Furthermore, this study may be significant to the following. The outcome of the study would benefit the local government to have additional knowledge about the flooding in their area and how will they take action about it. This research may also benefit citizens to have awareness on how they will act and about the causes and effects of flooding in their area. Next, the results of this study would help researchers to gain knowledge and experiences about the causes and effects of flooding in their vicinity. Lastly, the study could also be beneficial for future researchers that will also conduct the same study, and furthermore use this study as the references and improve their study that they will conduct. On our review of related literature found the first topic, which is about the Santa Rosa-Silang subwatershed. It is said that there are 24 watersheds around the Laguna de Bay, and Santa Rosa-Silang subwatershed is one of these. According to the study conducted by Tongson, he specified the exact location of the Santa Rosa-Silang subwatershed, which is displayed on this slide. It actually covers areas of Santa Rosa, Piñan, Cabuyao in Laguna Province, while some parts of Silang in Cavite. This area is totaled to approximately 120 kilometers squared. The total population of the watershed is 570,000, in which the majority came from the city of Santa Rosa. The Santa Rosa River is classified as Class C according to the DENR. Based on DENR Administrative Order No. 3, Series of 1990, this part of waters is protected due to the reason that it can be utilized for the propagation and growth of fish and other aquatic resources. It is also classified as the recreational water Class 2 and as an industrial water supply Class 1 for manufacturing processes after treatment. The land conversion within the areas of Santa Rosa-Silang subwatershed plays a major factor in the area's flooding and water pollution. There are different drivers of land conversion on upstream and downstream areas of the said watershed. The land conversion on upstream areas such as Silang Cavite is associated with the deforestation, plantation of pineapple, coffee, and abaca. This in-migration and planting of crops led to the soil erosion and soil acidity, while in downstream areas like Santa Rosa, flooding is due to the conversion of rice fields into the industrial and residential lands. These housing projects resulted in 5-meter increase in the lake's water level that can be seen on Barangay Macabling on Santa Rosa, Laguna.
In addition of related literature, it is under the Disaster Risk Reduction Management to Flood. In accordance to the World Health Government, more than 2 billion people in the world were affected by flood in the year of 1998, 2017, and especially to individuals who have poor knowledge of flooding and awareness of the phenomenon. That's why we, the researchers, will want to establish a proper risk reduction management due to this phenomenon. In also in according to the World Risk Report, in 2018, the Philippines ranked up to the third overall with the high risk in flooding with 25.14% index value. So with this study, we would like to be giving people of the particularly in the community of nearly Santa Rosa and Silang SUBWATERSHED to have a proper risk reduction management to least the risk and possibility of damages due to this kind of phenomenon of flooding and typhoon. That's why we the researchers will assess the causes and effect and give this study to the people that might be interested and give some feedback and also use proper methodology to overcome this phenomenon.
My name is Vherlyn Kaye Bernal, and I'm here to discuss about the resilience to flooding. Flood resilience is a concept that has become more widely used, and it basically means that damage is reduced during periods of flooding, leading in less threat to health and facilities, and maintaining that there is enough space for flooding and river modification where it is possible. It also ensures that flood relief will be less costly and bring people back on their feet faster than in previous floods, and that the water supply will not be harmed and will be able to recover on its own. Resilience is a subject that is currently being studied all over the world. So study on resilience has been described as bridging the gap of conventional disaster risk and weakness approaches, as well as expanding the emphasis to natural disaster-prone populations' potentials, prospects, and capacities. So here in the Philippines, socioeconomic research on resilience is slowly gaining traction, according to Lanto 2016. As the country needs more in-depth empirical studies on the macroeconomic and microeconomic vulnerability, as well as how systems resilience can be boosted and strengthened. Resilience is now regarded as one of the most important outcomes of disaster risk mitigation, as it broadens the focus to include not only the system's ability to predict and plan for the dangers association with a threat, but also its ability to react to and respond from these hazards once they happen. According to Mayunga 2007, developing an operational concept of resilience, as well as defining and evaluating its primary measures or factors, is extremely difficult. Assessing resilience at the community level is critical because it is here where the negative effects of a catastrophe are most experienced and where adaptation takes place. According to Razafindrabe, a strategy is needed to be implemented in a few barangays in the Laguna Lake region. So the method consists of 3 key steps wherein they need to establish a barangay level flood risk profile, establish a barangay level flood disaster resilience profile, and also the mapping of total municipality disaster flood management resilience. So, our local government units or the LGUs and other stakeholders interested in local disaster risk reduction program may use this tool as a starting point for targeted strategies.
According to Inguilio, the DPWH of Quezon City said that the leading causes of heavy flooding are due to garbage waste on canals, creeks, esteros, ponds, rivers, and other major waterways. Due to urbanization, the stormwater channels become less, and inadequate drainage system are the common flooding problem as well. In terms of hydrological causes, floods are due to impermeable land surface with saturated water, poor infiltration rates, and land erosion.
The effects of flood. So, over the past decades, recurrent flooding associated with typhoons, monsoons, and heavy rains has proven to have major effects on the Philippines. So, recent large scale floods associated with typhoons Haiyan, which is Yolanda in 2013, Bofa or Pablo in 2012, Nesat or Pedring in 2011, and Washi or Sendong in 2011 as well, and also Ondoy and Pepeng in 2010 have all led to massive flooding. The amount of damage caused by tropical storms leading to flood, both in terms of life and economic losses, can be devastatingly high, and these can have overwhelming impacts on the megacities of developing countries. So the effects of flood has educational effects as well. So, in the educational sector, small scale floods that frequently or permanently affect schools and community, especially in Metro Manila, contribute to making those places less conducive for learning.
So my name is Vherlyn Kaye Bernal and I'm here to discuss about the methods used in the study. So the study uses the disaster risk assessment guidelines established by the country's National Economic and Development Authority or NEDA, and it is in collaboration with the United Nations Development Program and the Executive Committee on the Humanitarian Affairs as a method for local governments to use in disaster risk reduction and management. So for the methods in knowing which places in Santa Rosa-Silang SUBWATERSHED vicinity are vulnerable to flash floods, the geographical data of Santa Rosa-Silang SUBWATERSHED must be identified, which includes the digital terrain model, the land map, and the soil map of the city. So the picture starting from the left is the recognition digital terrain map or the DTM of Santa Rosa Silang SUBWATERSHED. And then the middle picture is the 2014 land cover map of Santa Rosa Silang SUBWATERSHED, wherein the red parts are the residential or urban part, wherein the overall area is 4,353.91 hectares. And then the percent of subwatershed area is 42.88%. Then the second biggest area is the pasture, which covers 2,527.95 hectares with the percent subwater area of 24.89. And then the others consist of orchards, forest or mix, and agricultural or generic. For the last picture, it is the soil map of the Santa Rosa Silang SUBWATERSHED, wherein the loam, which is the purple color area of the Santa Rosa, has the biggest area, which is 4,732.05 hectares with a percent subwater area of 46.60. Then the next is the clay, which is the brown part, which has 3,133.82 hectares with a percent subwater area of 30.86. Then the next would be the claim loam, which is the blue part of the area. And then the next is the sandy clay loam, then sandy loam, and the smallest will be the mountain soils. Then a SWOT model was needed, where it is the compiled and converted climatic data of Santa Rosa from the 1980 to 2015. So basically, what will happen is that the DTM map was imported into the model's platform, and outlets and streams were generated based on elevation changes in the region. And the result will be discussed next.
Going to the results and discussion of our study. So it was found that areas vulnerable to flash floods are HRU number 8, number 13, number 15, number 21, number 22, and number 26. So the result of the study identified that these HRU are again vulnerable to flash floods based on its physical characteristics and its exposure to extreme amount of rainfall. The research showed as well that the areas or HRU number 3, number 4, and number 19 are prone to sedimentation. So these are the areas that is near a downstream along the riverine system and lakeshore and is therefore or makes it very vulnerable to sedimentation. So that is Barangay Apply Shoreline. And here are the actual images and a sketch of Barangay Aplaya. And lastly, to find out the areas vulnerable to erosion, was concluded that those are HRU number 33, number 37, number 40, number 42, number 44, and number 47. So the portions vulnerable to erosion are mostly in a sloping upstream areas within Silang and midstream areas along in Santa Rosa. So here's a sketch depicted or an actual image showing Barangay Santo Domingo in Santa Rosa and Barangay Tartaria within Silang Cavite.
Conclusion: the soil and water assessment tool or the SWOT model was used to analyze the flood hazard and used to determine the surface flow and sediment yield volume based on the data provided. The result found that high volumes of runoff in downstream and midstreams in the vicinity of Santa Rosa and the people residing along of it are vulnerable to flooding. Erosion occurs in sloping areas and sedimentation in riverine in downstream. This study is recommended to future researchers to further simulate the related cases in different municipalities, and to disaster risk management to formulate latest version relating to flood and landslide risk and to develop new strategies relating to flood hazards. And once again, I am Jasha de la Cruz and thank you for listening and always keep safe.